Alright, here we are again for the second part on similar shapes. This is where we're going to be dealing with 2D and 3D shapes. So, let's get started. Now, remember, I could have two similar shapes. That one and that one there. And okay. Let's leave it like that for now. Because I want to illustrate a point. Okay, let's leave it like that for now. Let's say they ask you to find the area of that shape there. Okay? Well, you may be inclined to do the following. I could find the length scale factor, which is 9 divided by 3, which is 3. So you can think, aha, the area of this shape here is 15 centimeters squared. So the area of that shape there is going to be 15 times 3, 45, right? That kind of makes sense, doesn't it? But that is the wrong thing to do. That is not correct. And the reason why is as follows. If that side is 9, because 3 times 3 is 9, and that's okay, that makes sense, then this side here is going to be 5 times 3, 15. So the area of this shape here is not going to be 15 times 3, 45, is 9 times 15, which is 135 centimeters squared. So it's not, the two areas are not in a factor of 3. This area is not 3 times bigger than that. The area scale factor is 135 divided by 15, which is 9. So, when you have to find the area of one similar shape to another, you cannot find the length scale factor. You have to find the area scale factor. But there's a link between the two, which will make your life easier. What's the relationship between 3 and 9? And you're going to say add 6 or multiply by 3. But basically, 9 is 3 squared. Because when I tried to find the area, I've multiplied one side times 3, the other side times 3 again. So times 3 is times 9. So, big thing you have to learn, the big learning point here, is that the area scale factor is the length scale factor squared. That's what it is. So this is the one thing you have to highlight and learn and make a note of, and then I'm going to show you an example on how it works. So I might have a regular pentagon there, side length is 5, I may have a bigger pentagon where this is 20, and then tell me the area here, I'm going to make the numbers up, it could be wrong, is 80 centimeters squared, find the area of the big pentagon. So, the length scale factor, I find two corresponding sides, 20 divided by 5 is 4. So I've got my length scale factor. But remember, we cannot do 80 times 4. We have to find the area scale factor, which is the square of the length scale factor. So 4 squared is 16. So the area of the big shape is going to be 80 multiplied by 16. So the area here is going to be 80 multiplied by 16, which is going to be 800 plus 480 1280 centimeters square. If my mental math is correct, please check it. So that's how it works. And similarly, like we did with the similar triangles, they could give me the area of the big shape and ask me to find the area of the small shape. So we'll do it exactly the same way. Find the length scale factor, square it to find the area scale factor, and then I will do 1280 divided by 16 to find the area of the smaller shape. So that's how it works. And again, you must take notes, copy the examples out, and make sure it makes sense. And finally, we're going to look at volume. So we're going to extrapolate this into volume, but hopefully you can make a connection and see what is going to happen next. So, I don't know, here is small cuboid, and here is the enlarged cuboid. Let's say this is 8, let's say this is 16, and let's do things the other way around. Let's say the volume of this cuboid is 240 centimeters cubed, and I want to find the volume of the smaller cube. So let's do it the other way around now. Okay, as usual, we're going to start with our length scale factor. 16 divided by 8 is 2, nice number. But now, because I'm dealing with volumes, I'm not going to find the area scale factor. I need to use the volume scale factor. So, if the area scale factor was the length scale factor squared, what do you think the volume scale factor is going to be? It's going to be the length scale factor cubed. So the volume scale factor between these two shapes is the length scale factor 2 cubed, which is 8. So once I've got the volume scale factor, the volume of the small shape is going to be, how do I go from here to there? I need to divide by 8. So the volume is going to be 240 divided by 8 is 30. So 30 centimeters cubed. And there you go. That's my answer. This is how you find volumes of similar shapes. I'm going to do one more thing. It's going to be extensive here and give you a more exam type question where you have to convert between area and volume scale factor. So there's got a bit of information here, but just do it slowly, one at a time. You'll be right. You'll be okay. Right. I don't know. That looks almost like a cylinder, and then that's my kind of enlarged cylinder. Apologies for the atrocious drawing skills, but there you go. The area, or the surface area of that cylinder there is 40 centimeters square. The area, surface area of that big cylinder is 120 centimeters square. And they tell me that the volume of this is, again making the numbers up, doesn't necessarily have to add up, 30 centimeters cubed, and they asked me to find the volume of the big one there. Here I don't have lengths, but I know the surface area of the two cylinders. So I can find the area scale factor. And the area scale factor is 120 divided by 40, which is 3. And with that, I can find the volume scale factor. And you may have thought that maybe the volume scale factor is the area scale factor squared, but it doesn't work like that. Whenever you have to go between surface area and volume scale factors, you always have to go via the length scale factor. So remember, we found out earlier, put as an aside, the area scale factor is the length scale factor squared. We remember that from before. And the volume scale factor was the length scale factor cubed. So if I know that, and I want to find that, the length scale factor is going to be the square root of the area scale factor. Because I'm going backwards now. So the length scale factor is going to be the square root of 3. And for now, I'm not going to find that out in the calculator. If you do square root of 3, it will give you 1 point infinite decimals. So just for now, leave it. Once I know the length scale factor, I can find the volume scale factor, which is going to be the square root of 3 cubed. Whatever that is in the calculator, don't figure it out just yet. So then, to find the volume of the big shape, I need to take the volume and multiply by the volume scale factor, which is the square root of 3 cubed. So now it's when I get my calculator out, and the volume is going to be 30 times here we go. Calculator ready. Square root of 3 is 1.73 something or other. If I cube it, I get 5.1 and blah blah blah. Multiply by 30, and I give my answer rounded to, well, I'll press something I should have. Square root of 3, cube it, times 30, rounded to 1 decimal place. 155.9 centimeters cubed. And that is kind of, well, that's a perfectly good exam question, GCSE level. So, I've seen this kind of question appear many times in the official GCSE exam. This is the kind of thing that if you're aiming for high grades, you are expected to be able to do just like that. And it's actually not that complicated if you've managed to get your head around how to switch between the length and the area scale factor and the volume and the area scale factor. Bit long, I've covered a lot of things. This is a lengthy topic, so what I would like you to do, as usual, is watch, rewind, watch again, take notes, pause, ask if you need help, and then do the work and do the questions, okay? Thank you very much. I'll see you later. Take lots of care. Bye.